Hey guys, we're super excited today. We're here at Altitude Consulting and we are going to get our WESA Panheads cyanescence tested, and we're happy to take you along the journey of what HPLC testing is and how it works. How you doing?
Hey, I'm doing well. How are you?
This is Chase.
Hi, I'm Chase. We're here at Altitude. Let's go check out the lab.
Hey, how you doing, Colton?
Good.
This is Colton, the lab manager at Altitude Consulting. Can you walk us through how HPLC testing works?
Absolutely. The first step whenever you're doing HPLC testing on psychedelic mushrooms is we need to homogenize and grind the sample down. So to do that, we're going to use liquid nitrogen. Come on, there we go. Okay, so the reason we use liquid nitrogen is if you just try to grind these things without using it, it's going to be really difficult and you won't be able to get it into such a fine powder. And so essentially the liquid nitrogen is going to help our extraction solvent get into all the different parts of the actual sample. And we just start kind of gently grinding this down. So again, the reason that we want to grind this all down is, one, we want to homogenize the sample, so the individual mushrooms that you find within a couple grams, something like that, they can have variances of the potency. And so by having a larger sample size and then grinding it, you're basically going to get a more accurate or more representative sample of something like an entire flush. To actually run the test, we only need a couple hundred milligrams, but again, we generally ask people if they're actual, fully mature mushrooms or just intact mushrooms rather than ground. Then we ask for a couple grams at least. And again, that's just because if you submit just a single mushroom, that's not necessarily going to be representative of your entire grow or an entire flush. But if you powderize yourself or homogenize yourself, then we really need a couple hundred milligrams at the absolute minimum, but we still ask for at least half a gram. All right, so we're getting down to the bottom of it here. You can pretty much see that the liquid nitrogen has evaporated. And so now, rather than fully intact mushrooms, it's starting to turn into a powder, which is what we want to see. All right, step one is complete. Now we'll actually start the extraction. This is where we have the balance, extraction solvent, a lot of tools. For something like biomass, it's really simple to do an extraction. All I'm gonna do is grab an extraction vial right here. We'll write the work order on it. This is just so that we keep everything organized. So what I'm doing is putting the extraction vial on the balance. Then I'm gonna zero the balance out, weigh out about anywhere from 150 to about 200 milligrams of biomass. So we'll see how much that is. All right, so it's 153.4 milligrams. And the reason I'm writing that down is that's gonna help us do the calculation in the end, figure out what the actual concentration is. So next, what I'm gonna do is, now that we have our biomass, we have to actually have a way to get the things like psilocybin and psilocin out of it. So the way we do that is using extraction solvent. And so there's different types of extraction solvents you can use. Depending on time, you also have to worry about things like degradation. And so in our case, we're gonna use methanol. So what I'll do is put 10 mils of methanol in there, and this dispense setup here is just calibrated to be 10 milliliters. And it's important to note that all the equipment in here, since we're ISO 17025 accredited, all the equipment that we use is going to be calibrated by ISO 17025 vendors. And so that's just going to ensure that the numbers, like where we get the 153 milligrams for the extraction weight, that's actually 153 milligrams. Because if you have a balance that you get off like Amazon or something like that, if you drop that thing down the stairs, you know, they can be set off easily. And so we have to recalibrate these and get them verified multiple times a year. So that's what this guy up here is. It's basically just ensuring that I don't have to go through and manually measure out 10 mils. This thing is just calibrated to do that every single time. So once we have our extraction solvent in there, there's a few different ways that we can go about the next step, depending on how quickly we want to run the analysis. Our general turnaround time is 48 hours. And so that's when we would do sort of a slower overnight extraction that it doesn't take much time when it's very hands-off. But if we have to do something very fast, we also have a method for that. If we're not doing the normal turnaround time, say someone needs something really fast, we have this super cool instrument right here. It's basically an ultrasonic probe. And so what it does is it's just gonna basically be pushing a high amount of energy into whatever we put into this capsule. And so the parameters are set on here. I put them on our Patreons we've used this thing to make some of the extracts and things like that. But in essence, it's just gonna speed up the entire process so that instead of it being an overnight extraction where it's a lot hands-off, I can just come over here, turn this thing on, and you can see how powerful that thing is in there. You can see that the entire solution in there is actually just getting really mixed up. And the other thing that the ultrasonics is gonna do is it's gonna break down the cell walls that the biomass, a lot of the psilocybin and actives are actually held within. It's the reason why the extraction goes from being an overnight extraction to being maybe half an hour, is because this thing is just super powerful. It basically just blows up those cell walls, and then the extraction solvent can just do its job a lot easier. All right, so say the overnight extraction's done, or we did the ultrasonic probe. Now what it's time to do is actually prepare the sample to go on the actual instrument. So what I'm gonna do is we take our extraction vial, and I'm gonna filter out the biomass, because at this point, our extraction solvent is going to have contained the actual compounds that we're looking for. So I'll filter this guy. Now, rather than the big extraction vial with all the biomass and all the gross stuff, now we've just got our actual sample that we'll put on the HPLC. So now, last step is actually putting the sample on the instrument. So before I do that, let me explain what I'm actually looking at here, what we're looking at. So this whole stack right here is the HPLC. So this is the instrument that we're using to actually run the analysis for things like potency of psychedelics. So up top, you'll see these bottles. This is what's called your mobile phase. Depending on what you're running, these will differ. What's basically going on is the mobile phase is constantly pumping through this entire system. And while it's pumping through, what I'm gonna do is take our sample and I'm gonna put it into the sequence on here. And you can see that this arm, basically what it does is it grabs a sample and it's gonna inject a very small amount into the instrument. We're talking like 1 to 10 microliters of sample. So it's not very much, but the detector is so sensitive that it really does not take much to actually get an absorbance in this case. Once you actually get the instrument running and it starts injecting a sample or a standard or a blank, what happens is the sample now is going through that same loop that the mobile phase is, and it's going to go through what's called the column. And the column is probably the most important part of HPLC. And in essence, the column is going to separate out the analytes and the compounds prior to hitting the detector, which is down here. In this case, this is a UV vis detector, a DAD, which means diode array detector. But again, the column is going to separate out your analytes prior to hitting this thing. And the reason that's important is because you can imagine that if you just inject a sample, it's not just going to contain psilocybin, it's not just going to contain psilocin, it's going to have all these different compounds in it. And if you just hit the detector with everything all at once, it's going to be overloaded, and you're not going to be able to know what caused an absorbent. Was it psilocybin that absorbed? Was it psilocin that absorbed? Or was it something else entirely that has nothing to do with what we're trying to figure out? For the quantitative part of the analysis, this begins with the reference material. So reference material is also called standards, and there's different tiers of standard. The lower tiers are just called analytical standards, which generally will have a potency or a purity of about 95%. The upper tier, or the highest tier, is called certified reference material, or CRM for short. So right here you can see this is a CRM standard for psilocybin. And again, because we're ISO 17025 accredited, we're required to use CRM standards whenever they're available. And so basically what I'm going to do on the quantitative aspect with that reference material is I'm going to take it, and the CRM has an exact known potency. That's what is the difference between just an analytical standard and a CRM. And so since I know the exact potency of, say, that psilocybin standard right there, when I go to inject something on the instrument, I'll know exactly the concentration of psilocybin that's going to hit the detector. And so in essence, what I'm going to do is I'm going to shoot, say, 1 microgram per mil of psilocybin onto the detector, and I'm going to get some absorbance. And again, the reason I know it's 1 microgram per mil is because I'm taking it from the CRM, and so I know that exact concentration of psilocybin. So just for argument's sake, let's say that I spike that 1 microgram per mil onto the instrument, it hits the detector, and I get an absorbance of 1. Then what I'm going to do is I'm going to shoot 2 microgram per mil of the standard on here, and let's say that gives me an absorbance of 2. I'm going to keep doing this, and what I'm doing is building what's called a calibration curve. And so in essence, then when I go to shoot a sample, let's say I get an absorbance of 2. Well, I know that it took 2 microgram per mil of psilocybin standard to get that same absorbance, and so now I know that the sample has to have had 2 microgram per mil of psilocybin to actually cause that absorbance. And that's basically how we calculate the concentration of the analytes in a sample. So something that's really cool about the Panheads is that we don't see this in cubes when we're doing the analysis, but generally everything I've been talking about is absorbance. That's the quantitative way of how we're actually measuring these different analytes. Something that's super interesting about the Panheads is that there's these peaks, or specifically one peak in here, where instead of the peak going sort of in a positive manner, it's going in a negative manner. So instead of above the baseline, you actually get a dip in the baseline. And so the opposite of absorbance would be emitting. There's something in these samples, again, that's specific to this species. There's actually an analyte that's emitting rather than absorbing at the current wavelength that we're analyzing. Currently, I don't have any way of knowing what that peak is.